Temporary setback. The camera froze. But I noticed it pretty quickly. So all I was doing was I wrote 0.34 plus 4.57 and 10 times 10 to the fourth, because now since they both have the same power of 10, I only need to have it there once. So when I add these two together, 0.34 plus 4.57, we get 4.91. Keep the power of 10 times 10 to the fourth. Now the thing to be aware of is when we're doing these operations is that if the new leading factor either winds up being 10 or greater or less than 1, we're going to have to adjust our power of 10. And I've got an example like that right here. So I have here 1.33 times 10 to the negative 2 minus 4.2 times 10 to the negative 3. And I even made it a point to make it negative so you see what to do when we have those negative exponents. So the first thing I'm going to do is I'm going to look and I'm going to notice, again, I've got my negative 2, I've got my negative 3. What we need to remember is that when we have negative numbers, the number that's closer to 0 is the bigger number. And that's negative 2. It's only 2 away from 0, whereas negative 3 is 3 away. So it's farther away. So what I'm going to do is I'm going to change this second one. So I'm going to do, this is going to stay the same, 1.33 times 10 to the negative 2 minus, now again, in order for me to make this number bigger, alright, this has to increase by 1, so I have to make this smaller by a factor of 1. I have to divide it by 10. So my decimal is going to, again, move to the left. So I'm going to have now 0.42 times 10 to the negative 2. And then just like I added up here, I'm going to take my leading factors and I'm going to subtract them. So 1.33 minus 0.42. Keep the power of 10 times 10 to the negative 2. So now when I do this, and I do 1.33 minus 0.42, I'm going to get 0.91 times 10 to the negative 2. And so if I'm not paying attention, I might be like, good, I'm done, I can move on. The problem is, because our leading factor is not a number between 1 and 10, this is not scientific notation. So in order for us to now have this actually be in scientific notation, I have to make this bigger. So this has to increase by a factor of 10, which means that this now has to decrease by a factor of 10. So our answer is actually going to be 9.1 times 10 to the negative 3. Because remember, this is going to go more negative. So that's why we go from a negative 2 to a negative 3. Negative 3 is more negative than negative 2. So that's the really tough stuff. Okay? Addition and subtraction. Just like with fractions, when you're adding and subtracting fractions, it makes it more difficult because there's more you have to worry about. Multiplication and division, however, are not that bad. So with multiplication, it's relatively straightforward. When we multiply, we're only going to multiply our leading factors. Our exponents we're going to add. So I look here, I see 2 times 10 to the third times 4 times 10 to the fourth. So all I'm really going to do is do 2 times 4, and then I have times 10, and I say 3 plus 4. So I'm going to add my exponents. 2 times 4 That's just 8 times 10, and we got 3 plus 4 adds up to 7. That's my answer. 8 is between 1 and 10. We got a power of 10 there. The problem to look for when we're dealing with multiplication now is if my two leading factors, multiply to a number that is 10 or greater. So like in this example here, 5.4 times 10 to the second times 3.1 times 10 to the fifth. Again, I'm throwing a negative in there so we can see what happens with it. So again, I'm going to set it up just like I did with this one up here. I'm going to multiply the leading factors. 5.4 times 3.1. I'm going to have it times 10, and I'm going to add 2 and negative 5. 2 plus negative 5. So when I do this, 5.4 times 3.1 is going to give me 16.74 times 10, and 2 plus negative 5. Different signs means we're going to subtract, and we're going more negative, so our answer is going to be negative, and 5 minus 2 is 3. So we get a 10 to the negative 3. Well, here's the issue. 16.74 is greater than 10. So we have to make this smaller. So I have to move my decimal one place to the left, which means that if I'm making this smaller, I gotta make this, my exponent, bigger by a factor of 10. So I'm just gonna add 1 to the exponent. So when I do that, I get 1.674, that's between 1 and 10, times 10, negative 3 plus 1, I'm going less negative, so it's now going to be a negative 2. Division, similar, okay? It's just that now, instead of us multiplying our leading factors, we're going to divide our leading factors. And then with our exponents, we're going to subtract, because that's what we do when we divide powers. We subtract the exponents. So in our first example, we've got 9.60 times 10 to the 7th divided by 1.60 times 10 to the 4th. So when I do this, I'm going to do 9.60 divided by 1.60 times 10, and then I'm going to do 7 minus 4. 9.6 divided by 1.6 is just 6 times 10, 7 minus 4 is 3, and there we go. Okay? Our last example is, what if we divide and the number we're dividing is being divided by a number that's larger than it? So an example, here we have 2.4 times 10 to the 8th divided by 3.2 times 10 to the negative 4. It's a little tough to see it because I drew it kind of small, but that's a negative 4. Again, I'm going to take the same steps I've been doing. I'm going to divide the top by the bottom, so 2.4 divided by 3.2, and I'm going to subtract the exponents. So 10 to the 8 minus negative 4. So when I do 2.4 divided by 3.2, I get 0.75 times 10, and when I do my subtraction, 8 minus a negative 4 minus a negative becomes plus a positive, so I'm actually going to do 8 plus 4. So I get times 10 to the 12th. So again, 0.75 times 10 to the 12th. it's not scientific notation because 0.75 is less than 1. So I need to make that 0.75 bigger, in this case by a factor of 10, so I'm going to make it bigger. I'm going to move the decimal place to the right one. That means now that my exponent has to drop down 1. I have to lessen it by 1. And when we do that, now we have 7.5 times 10 to the 11th. So again, my 0.75 became a 7.5 because we increased it by a factor of 10. My exponent of 12 decreased to now an exponent of 11 because our power of 10 decreased by a factor of 10. And so this is our answer in scientific notation. I hope this was helpful. If you guys found it helpful, like and subscribe, and we'll try to keep doing this, and I'll try to keep helping you guys with math. I'm Mr. Oakes. Have a good one.